Hello, thanks for the invitation, Jordan. This is Bocho. Uh, I'm an organic chemist from University of California, San Diego, and today I want to talk a little bit about ionum and chemical structure and synthesis. And hold on, let's get started. So a little bit about the structure. So ionon is derived from the Greek word iona, which means violet, and non for ketone. And you have three constitutional isomers as shown here. So the alpha, gamma, and beta ionol, they have the double bond at the different position, while the beta ionol is in conjugation with the alpha beta unsaturated ketone, while alpha and gamma ionol will have a higher center right here. And they are 13 carbons, terpenoid, also called isopenoid, just like what we talk about in lectures about beta-carotene, which is also isopenoid, derived from the isoprene units here. So actually, in fact, beta ionol can actually be biologically synthesized from beta carotene, just like the way that it can be synthesized, just like how we can synthesize vitamin A, which is retinol. So beta ionol can be synthesized through the enzyme called BCO2 or beta carotene oxygenase, or it is also called CCD, which means carotenoid cleavage dioxygenase. And we said that the nature is the best organic chemist, but it has one thing that it doesn't do really well, which is it cannot provide good quantity of the product that we want. So let's say if you want to make a perfume out of ionol from natural flowers, from violets or rose, you actually need to extract them, as Jordan mentioned. But in order to get 1 kilogram of ionol, you actually need 33,000 kilograms of violet flowers. So that's a lot of flowers, and it is time consuming, expensive, and most importantly, it is a waste of beautiful flowers. So that is when organic chemist comes into play. So in 1893, two chemists called Tielemans and Krugers, they developed this really beautiful two-step reactions to produce all three isomers of ionos. So the only starting material you need is citral and acetone, which are really easy to obtain. And this reaction is really easy to be achieved under mild conditions. So the first step of the reaction is autocondensation with base catalysis to produce something called pseudo-ionon. It is a acyclic alpha beta unsaturated ketone. And then the second step, this pseudo-ionon is cyclized on the acid catalyst to produce to produce the different isomers of ionos. And the beautiful part of this reaction is that you can achieve reduced selectivity by choosing different acid catalysts for the second step. So for example, if you want alpha catalyst, you can use weaker acids such as phosphoric acid, and to get more iode in the beta iono, which is the more thermodynamically stable product, you will use a strong acid such as sulfuric acid. And for gamma iono, you will use the Lewis acid such as BF3. So yeah, so that is the power of organic chemistry. And I believe that's what I have so far. Thank you so much, and Bochu out.